you doing? I'm MPC. Today I'm making another tutorial for you guys. Today's tutorial is going to be another addition to my GMStudioPhysics series, and today the thing we're going to be learning is impulse. Impulse is a lot like force, only when you have a force over a small period of time, it's generally very large, and it's generally more efficient to think of it in terms of impulse, because impulse is when you have like an instantaneous thing which just happens in a second, doesn't depend on how much time it's being applied. Force is thought of as like a persistent thing that's applied for a certain amount of time that affects it over time. Think of it if you want to get something to go from 0 to a decent speed, and you have like a small fraction of a second, it'd be a tenth of a second or something like that. Well, you need to have very high acceleration because you need to accelerate to that speed in that amount of time, and with a small time, you need high acceleration to get to decent speed in that amount of time. So it's oftentimes not efficient to think of it as a force, because at such small changes in time, the force needs to be really high, which doesn't connect with the results oftentimes. And when you have such a small change in time, you often don't care how much time it is, you just think it's pretty much instantaneous. It could be a tenth of a second, it could be 20th of a second, I don't really care, it's pretty much instantaneous anyway. And that's a big deal for the force, what change in time, but for impulse, doesn't matter at all, change in time. So that's why I use impulse versus force. Oftentimes when you think of it in terms of impulse or small changes in time where a lot of force is being transferred, is during collisions. So you think of a bouncy ball hitting the ground, it'll hit the ground and go back up, and during the time when it's hitting the ground, it's a very small change in time. Just looking at it seems instantaneous, but there is a very small change in time when it's touching the ground, and during that time, the ground applies enough force to the ball to make it go upwards at basically the same speed as going down. I found a slow motion video online of a pool ball hitting the edge of the pool table and then bouncing back, and it's in slow motion so we can really nicely see the amount of time where it's hitting the side. And I'm just going to go ahead and run some calculations on it, I think. So we're going to assume that's approaching the side at 10 meters per second, which is a pretty decent speed for pool balls. It's about the right speed that you would go at. Then we're going to say it bounces back, so then it hits the wall, and then it bounces back at negative 10 meters per second. It's going the opposite direction. Alright, so we're going to say the amount of time that's actually hitting the side is, let's say, a 20th of a second. So that's what we have to work with. Let's go ahead and calculate the impulse. Okay, so force is equal to mass and acceleration. Impulse is equal to force times change in time, which we can also think of as, instead we can think of impulse as mass times change in velocity, because change in time times change in acceleration, change in time times acceleration is change in velocity. And by the way, you'll see on the screen that I use these triangles, that's called delta. That's the same as saying change in this, only change in this takes up a lot more time, so we use the delta symbol. That's how people do it in physics. It just saves time is the main reason why they do it. Okay, so where impulse is equal to mass times change in velocity. Alright, so we're going to say the mass of our pool ball is about 0.15 kilograms, 150 grams, and then the change in velocity, so starting at 10 then goes negative 10. So the difference in that is negative 20, so, because you need to subtract 10 for it to bring it to a stop, and then you need to subtract another 10 to make it move to the left at the same speed. So negative 20. So put that in the calculator, 0.15 times negative 20. You would get negative 3, which is a very nice, easy to work with number. Alright, so now let's calculate for force. So, force equals mass and acceleration. Alright, acceleration is how much the velocity changes in 1 second. Meters per second, how much velocity changing per second. So we know the velocity change in a 20th of a second is negative 20. So to figure out how much acceleration that is in a full second, we would multiply negative 20 by 20, and so that would bring acceleration to negative 400. Alright, multiply negative 400 by our mass of the pool ball, mass and acceleration, and we get 0.15 times negative 400, which is negative 60. Note that's a much bigger number than our impulse, much harder to work with. And also notice that it's dependent on time. If we change our time to 1/10 instead of 1/20th, force would become negative 30, while the impulse would stay at negative 3. So that's why impulse is so powerful, because we don't care how much time is changing. It's pretty much instantaneous as far as we're concerned. So we don't want to have to figure out how much time it's colliding and how much force you need to apply accordingly. We just want to apply this much energy at this amount at this time and just run with it. Alright, so that's what impulse is. I hope I gave you a good explanation of what that is. And what we're going to be making today is another addition to my physics simulation thing. And only this time we're going to, you click on the items, drag, and then when we release, it'll operate like a slingshot. It'll just be one moment where there's an impulse applied to the objects and it'll throw them around. Alright, so that's what we're going to do today. Yeah, let's get on with it. Let's get to it. Alright then, so let's get started. First off, let's go into Obj5. So right now we have a selected variable over here which decides whether or not it's selected for the dragging force thing. Well, we want to have another such variable for impulse, so we're going to rename this so we know it's in terms of force. So I'm going to call it cell force. And then I'm going to go through all of them to make sure we have that all taken care of. So selected cell force. Replace all. And down here, replace all. Alright, so now we can kind of get started. I'm going to go ahead and create another variable, and we're going to call this one cell impulse. Set equal to false. Then, let's see. We're going to have impulse been at the right button, while force at the left button, so let's go over to our right button. Mouse right pressed. There we go, so when we click on this guy, cell impulse is equal to true. And then, when we release the right button, so global.right released, then we want to apply the impulse, which is just one instant where it just explodes, I guess. Alright, so if cell impulse, okay, you can put down equals true there if you want, doesn't really matter. Now I want to apply the impulse. So, I'll just type down physics apply impulse. Alright, like force, you can also say apply local impulse, and I explained this already in force, but I'll just go through it again. So if you do this, you're doing it according to the world value. So if you want to make it go up, this you'll just have it go in a negative y direction, and that's all there is. But with local, if you made it go up in the same way with local, it will go up in relation to the object. So if you have a player and he fell down with his head facing to the right, I guess, and you try to make him go up, it would go relative to the player, and relative to the player's position, up is to the right, so it'll make go right if it's local, which is good in a lot of situations, but in this case we're just leaving it like that because we want to go in the direction that the mouse takes it regardless of what its orientation is. So the place it's going to be applied to is our XY. If you wanted to apply it off-centered, you would do something different, but whereas applying it middle just makes things nice and easy. And now our X force. Okay, so we make this work like a slingshot. So if our mouse is under the object and then we release, then we want to fly upwards. While with the force we want to go towards the mouse. So but here, as I just explained, it needs to go opposite for the mouse. So instead of doing mouse X minus X, we're going to do X minus mouse X. Just a negative. And by the way, I actually screwed this up when I first did this. I just want to point that out so that you don't get the impression that I know everything perfectly the first time. There's a lot of trial and error in coding, or no matter how long you've been doing it, really. I still have a lot to learn myself. So that's all there is to it. Physical apply impulse. These are the same numbers as force. So if we try to do this with force, we'd be applying force in one step, which would not work at all. I explained in the introduction how force and impulse works in terms of change in time and all that. So you notice that with our way our force works, it's constantly being applied. We take care of force in the left pressed, or sorry, global left button, and then impulse is being applied only once in the right release. All right. So we're gonna add one more event. We're gonna add the draw event, and over here we're gonna go ahead and draw a line so that we can keep track of what we're doing here as an impulse. And don't forget to draw a self first. If you have GameMaker 8 or lower, you'd have to do draw a sprite and then go through sprite index, image index, XY, and all that. But if you have GameMaker 8.1 or higher, then you can do draw self. It's very useful. Then, and this is another thing that I actually forgot in the tutorial. It drove me crazy. I actually started over because I couldn't figure out why my objects weren't visible, but that was just because of this. That was annoying. Alright, now I'll draw the line. we're going to draw it from where we are, so XY, to where the mouse is, so mouse X, mouse Y. There we are. I believe we have completed our program in all of about 5.5 minutes, so that's good. Alright, here we are. Oh, that's bad, isn't it? Yes, that's very bad. It looks cool. I think going over it looks cool. You can do some pretty cool stuff with lines if you know what you're doing. So there you go, I just messed up. But I know what I did wrong, so it's no problem. We don't want to always draw the line. We only want to draw the line when we are selected for the impulse. So if cell impulse, we draw the line. There we go. Now we can create objects. We can drag them around using force. And then now we should be able to fire them using impulse. That was very not satisfying. And I am kind of embarrassing myself right now because I have screwed my program up. Okay, but I know what I did wrong this time as well. Over here. After we apply the impulse, we want to set cell impulse equal to false again, because now we're no longer selected for impulse anymore. We're no longer selected for impulse, so not something we want to worry about. Okay, now it's going to work, I promise you. There we go. I do a little away from the block it launches. I found out the hard way that if I drag outside the screen like that, I'll get this error because it won't register for me releasing, and I couldn't figure out a way to fix that, so you'll probably come across that as well. Alright, there you go, impulse. I just drag it, and then I release, and in one instant, it will fire. As if you're curious, try changing the function to force and see how much less significant it is. Force applied in a single instant doesn't work, unless you have an extremely high force. And okay, it's come back. I thought we lost it there. And then another nice thing, now that we have all this figured out, is that the way it interacts with objects will be differently. It can fire things into objects. Really cool. In my Untitled game, I actually used impulse in the collisions with when you fire something. When you fire like a force at things, I used impulse for that. Alright, so that's the end of this tutorial. Thank you so much for watching. If you enjoyed it, I would really appreciate if you liked the video. It helps me out, and I always get very happy when I see people liking my video. I get even more happy if I see people commenting on it and telling me what they thought about it. I like hearing about what you guys think I should do better, what you guys think I should do in the future, because lately I haven't been doing a very good job getting around to comments, I'm sad to say, but I do like hearing it, and if enough people ask for something, I don't really have a choice, do I? So, and if you want to see more, please subscribe. I try to make these every now and then. I've been making a lot lately, probably get bombarded with them actually in the near future, so look forward to that. Alright, well, so I've probably talked far too long now. Thank you so much for watching, and I'll see you guys next time.